Today, in this Futoshiki, we're going to be exploring the less than rule within rows and columns. Now, with a Futoshiki like this row here in particular has got a prime example of a very useful rule, which is less than a certain number. So we can identify a number within this row by looking to see that this number is less than this one, this number is less than this one, and this number is less than this one. Now, given that all three of those boxes that I have just shown are less than something, the only number that cannot be less than something must go in this box, which is the number 5. So that starts off quite nicely. The next rule is looking for a 3 in terms with two other arrows pointing into it. So two inequalities going into a 3, because there is only one solution where this one is the 4 and this one must be the 5. Prime example where we can actually find values from other values. Now the next one is within this column here. We've got 2, 4 and 5, but this number has to be greater than this number. The only two numbers left in this column are 1 and 3. 1 is not bigger than any numbers that we can fill in, so our 1 must go at the bottom and our 3 at the top. Then leading into this column here, 3 must be greater than something here, which leaves a 1 or a 2. However, this must also be a 1 or a 2, as it is in the same column, but cannot be a 1 because of the one next to it. So this is our 2 and this is our 1. Moving along to the next area where we can look to try and identify some numbers are these 3 here. We've got inequalities going across, so this number is smaller than this one and this one is smaller than this one. So starting at the top here, this number could be potentially a 3, 4, 5 in normal conditions, meaning this is a 2, 3, 4 and this is a 1, 2, 3. However, we have got a 2 here next to this, which means these two numbers cannot be the number 2. We could have a 1 or a 3 here. We cannot have the 2, so this could be a 3 or a 4, and this one could be a 4 or a 5. So these are the only restrictions within these values here. So let's see where else in this row. We have got 1, 3, 4 missing. Now this number here actually will help us identify what these two can be. Because the only numbers missing are 1, 3 and 4, I'm just going to put them in for now so you can see. That would mean this number here would have to be greater than those numbers, whichever number it is going to be. So if this number was a 4, if this number was a 4, this would have to be the 5, but it can't be. If this was a 3, this would have to be a 4 or 5, but it can't be either of those two things. So it can't actually be the 3 or the 4. So this leaves us with only the number 1 here, and a 2 or a 3 above it. Now we cannot have the 1 here anymore because we have just placed that 1 already in the box, meaning this must be our 3, this must be our 4, and this must be our 5. So this is a prime example where just knowing that a number has to be greater than something can lead to actually solving 3 other numbers elsewhere. So we're left here at the bottom with a 3 or a 4. Now we've got a 3 here, so this one cannot be the 3 and must be our 4. And this one here must be our 3. So that means this can no longer be our 3 anymore, so it must be our 2. And we're left with 4s and 5s up here. However, we have got a 4 here, so this is our 5, and this one is our 4. We can now look going across that top row, and all the rows actually, as a matter of fact. This here, we're left with a 2 and a 5. There is a 5 at the bottom, so this one is our 2, and this one is our 5. Then along to this row, we've got a 3, 4, 5, so we're missing a 1 and a 2. There's a 2 above here, so this is our 1, and this is our 2, And finally, we can finish with the columns 2, 3, 4, 5. So this is our 1 and this one here is our 3. Excellent. If you enjoyed the video and found those tips useful, please feel free to smash the like button, and yeah, I'll see you in the next video. Thank you very much.